Hello everyone, Reza here. Welcome to another Unreal Engine. In this step-by-step guide, I will dive into creating blowing leaves from scratch using the Niagara VFX system inside Unreal Engine. I aimed to craft a unique scenario as an excuse to explore more exciting modules within Niagara, providing you with more tools for your future projects. Let's get started. Here I am inside the editor. I've got a very simple scene that I put together using Megascan assets. I have my materials also ready. For the leaves, I'm using maple leaves using Quixel Megascan. And as for the pavement, I'm using this surface right here using the same location, Quixel Megascan. So you can access both of these guys via Quixel Megascan. As for the material, this is totally optional, but I created my master material and then I made a material instance out of it. The good thing about material instance, as I explained in my previous tutorials, is you can actually promote and parameterize properties and bring them into a material instance. So I have one for base color, which allows me to tint if need be. I can make the leaves metallic if need be. I can play around with normals. I can change the roughness based on the weather and play around with specularity and change tiling, so on and so forth. Nothing too special. You really don't need to have a material instance, but I highly encourage you to use material instances any opportunity you get as opposed to a simple master material. Now, with that out of the way, I'm going to go into VFX and I am going to create a Niagara system. Just like before, we would like to create an empty Niagara system. So I'm going to click on that and I'm going to call that NS Blowing Leaves. Let's double click on this, dock that right next to our main level. And we need to create an emitter for our system. So I'm going to tap E on the keyboard to bring up add emitter to my system, and I will choose add empty Niagara emitter. I tend to use empty Niagara emitter most of the time simply because I would like to build stuff from scratch, and especially for tutorials it allows me to walk you through the entire process from scratch. Now the scene is ready. Let's go to the next chapter and start focusing on the properties within the emitter and our Niagara system. Let's start by renaming our emitter. So I'm going to go in there, Niagara emitter underscore blowing leaves. As for the main properties, for now, I don't know if I want to use local space, but I definitely would like to use determinism. And again, it allows us to get the exact same results with the same configuration. And I'm going to go and do the same thing for my emitter system. I would like to keep this as CPU, but calculating bounds, I would like to set that to fixed, and I would like to give it some sort of a bound. This is scene dependent, so have a look at your scene scale and how big the bounds need to be. So this is something that you need to look at your scene. I would like to start with -1000 all the way to 1000, so it gives me a really good coverage. So 1000, min -1000, max 1000. With regards to the main groups, we have emitter spawn, update, particle spawn, and particle update. I'm going to start with emitter update. Just like any other tutorials that I have created and explained, the very first module that I always add in the emitter update is the state. So I'm going to click on that, go to state, and drop in an emitter state. And this manages the life cycle of your Niagara emitter. You can call that from the emitter system, or you can set that to self and manage the life cycle within the Niagara emitter. So for this particular one, for the scalability, I leave that to the system. That's not a problem. For lifecycle mode, I'm going to go into self and set that infinite. Right now, the duration is set to 1. You can see in the timeline. And if I set that to 5, we get 5 seconds on the timeline. So that's a really good indication if you would like to know how long the life cycle needs to be. Remember, this has nothing to do with the life cycle of the particles themselves. This is the life cycle of your emitter. Don't get them confused. Now we have this state in place. Let's bring in either burst instantaneous or spawn rate. This is almost automatic every time you would like to emit set of particles and change their behaviors. I'm going to bring in spawn rate, and right now there is no particles being generated. I don't know the right value. I'm going to start with 15 and we will take it from there. The first question you might ask, and again, this is something that I went through step by step, especially in my volumetric smoke tutorial, is why you're not seeing anything. And the reason we don't see anything after setting the emitter is because we haven't picked any type of renderer. I'm going to click. We have ribbon, sprite, volume, mesh. In this case, sprite will work just fine. Remember, we have made materials for this sprite for this very reason. I'm going to go and select my material instance and drag and drop it here. Alternatively, you can select that, assign it with that arrow, or use the drop down to find your material and assign it to your sprite renderer. Let's go through some of these attributes. Source mode is going to be our particle, so obviously we are not going to change that. We're dealing with leaves. So I would like to be very specific with my alignment of my particles. So I'm going to go into custom alignment. And facing mode, I'm going to set that to custom facing vector. That helps me to show the particles correctly. And it gives us an indication on how particle billboard orient itself relative to the camera. Now the only thing I need to change is sub UV, simply because if I move forward with this, every particle or every sprite gets all of these 9 leaves within one particle, unless I go to sub UV and say the flipbook that I'm using is 3 by 3, so I can use sub UV animation in my particle spawn. You can do it now, you can do it later, but I'm gonna just do it now because I know for sure that this is going to be used. Now with emitter update out of the way and blocking out some values for my sprite renderer, I'm ready to go to the next chapter in the particle spawn and talk about how we can initialize our particles and define a location for anything that emitter update generates. So let's go to the next chapter. Now let's talk about particle spawn. And if you remember, modules in this stage should set up initial values for each particle. So we're thinking about life cycle, we're thinking about the size of the particles, the rotation of the particles. It is extremely important to set some standards for what type of particle we are going to create. I'm going to click. First module I'm going to create is initialize particle. So I'm going to go under initialization, initialize particle. As you can see, we have point, which is some generic information on our particle, and then we have, based on the type, sprite, mesh, ribbon. So I'm going to visit only these two. Point to access general information, including color, lifetime, and then using sprite to set up size and rotation. I'm going to start with the first tab, which allows me to specify the lifetime. Direct set is okay, but lifetime of 1 is way too short. I want these leaves to fall and to stay on the ground. So I might increase that to a very high number like 250. You can randomize that as well or extend this, but for now 250 is enough for me. Think about your shot, number of minutes or seconds that you stay in that shot before you cut to the next shot, and based on that specify the right value. Color mode, we are going to use textures, so there's no need for me to tweak any of this information here. I'm going to go into mass, and because I'm using leaves, I would like to give this a proper mass value. I'm going to set that to random for now, and I'm going to leave it as is, maybe make some of these slightly heavier based on the size, but I really would like to apply some values in there so we get a little bit of change when the gravity kicks in and pulls the leaves down. That should do it. Remember, we're just blocking out. We're not setting anything in stone. If we're getting a good result, perfect. If not, at least we know what to change and how to change them. The next one is to define what sort of area we're looking at. Is it going to be a cube? Is it going to be a cone? Is it going to be a sphere? What sort of location you would like to define for these particles once they get generated? So we definitely need shape location. And through shape location, you can define the type of shape: sphere, cylindrical, box, torus, ring, or cone. I'm going to go with good old sphere, and as I said before, there is actually a module called sphere location, which exactly does the same thing, but I tend to bring shape location to give myself a little bit of flexibility. If sphere is not working, I can switch to another type or shape. Now for shape location, 100 might be a bit too small, so I'm going to set that to something like 300, but again, I will keep an eye on it. We're not going to deal with any distribution at this point. We try to separate those particles using force field, but I'll leave that as default. I might change that later. Same with the transform. I really don't know what I need to change. We better put something in our scene to see if it's working and only then make necessary changes. So as you can see, some of these guys are popping up, but I'm getting exactly the same shape because I don't have sub UV animation. Well, that's a good time to add that to our modules. For the most part, sub UV animation usually goes under particle spawn. There are certain exceptions, but at least for this particular example is a no-brainer. We are creating those particles. We want those particles to be displayed correctly. So I'm going to type in sub UV animation. Let's bring that in. And it says, well, apparently you have some sort of a flipbook image. You assigned it to a sprite renderer. Just nominate that renderer, and we have only one sprite renderer, and we assign that. Sub UV animation mode is set to linear, and I set that to random, and I'm going to set the end frame to something like 3. Now, if you remember, in the sprite renderer, we set the alignment to custom alignment, and every time you do that, you actually need to tell Niagara what you mean by that. So initial mesh orientation is the module that I always use as a sort of a complementary module to clear the air with Niagara and tell Niagara how to display our particles. So initial mesh orientation. Let's bring that in. I'm going to drag and drop it on top of my sub UV, and it is already set to random, which I think works just fine for us. Now, I'm still not quite happy with the result I'm getting, simply because when we created our initialized particle module, we only focused on the points, not the sprites themselves. So right now, the sprites don't have any randomization. They look kind of identical, although sprite renderer is trying its best to sort of mix the textures. We haven't specified any value for the size nor the rotation. So let's go and make certain changes here. I'm going to go into random uniform because I want to set values. I'm going to make that something like 20 to 30. And I'm going to go sprite rotation mode and also set that one to random. Maybe 360. Well, the default works, so I'm not going to change that. We don't know. And now you can see we're getting a little bit of randomization here, which is much nicer compared to the unset state in the sprite section of our initialized particle. Now we've blocked out a few values. Definitely we need to tweak bits and pieces here and there, but I think it's a good time to go and put in some important modules within the particle update. Let's go to the next chapter. If I play my timeline, you can see that leaves are getting generated, but they're not really coming down on the ground. There is no wind, there is no force, no gravity, and that's why we need to address some important modules within the particle update. I start by using particle state in the particle update module. Every time you plan to use any type of force field, particle state is a must. I'm going to type in state and particle state pops up. That's the first one that you need in order to move forward. Then the next one on the list is to have solve forces and gravity, so everything gets calculated. So I'm going to type in force, solve force, and velocity. Most of the time you don't need to really change anything, but having this module is a necessity. Even if you forget and bring in, let's say, at velocity or drag or wind, you will see that you will get an error, and you click on fix issue, this module will get created. Now the first one that is a no-brainer is gravity, because these leaves are going to come down on the surface. So let's add that right now. I'm just going to type in gravity, force, and it shows up. It puts itself right on top of the solve force and velocity, and the default should work as this one is set to -980, pulling everything to -z. It's all good. Let's add a little bit of wind, but before that, let's check. Yes, they are falling down indeed. Let's add another force. Let's add wind, because we would like to have a little bit of wind. And again, based on your taste scenario that you're working, you may or may not want to have wind. I'm going to add wind, set that wind to maybe 180. We may go back and change this. With wind speed scale, I always randomize it. So if you don't randomize it, it's fine as well. It's not going to create any errors, but you get a more realistic looking effect every time you randomize a scale value when you're dealing with force, especially wind. So I'm going to go randomize range, and let's set that to something like 0.3 and 0.5, something very subtle at the beginning. We don't want to get too excited at this point. We'll see how we go. The next one is turbulence, which introduces curl noise. You can actually drop in a curl noise in here. We'll see if that is needed, or we can go with the default setup that we have. Scale mode, we want to set that to speed range and then play around with some of these attributes. So maybe 2.75 and 1, so you get a good intensity for the minimum, and for maximum let's crank this up to 500 as the default. 3500 is a lot. We don't want to go that far. For turbulence offset mode, time offset works well, but as you can see, the only axis that's been targeted is just Z. I want that turbulence to have an impact on all three dimensions. So I'm going to set that to maybe like 50. This one is 10. And let's intensify the Z-axis as well. Again, we are going to see how we go. Based on that, we are going to change these values. Now you can see I'm getting some sort of a warning or error. And this happens, especially with wind force. You need to have some sort of a drag or aerodynamic drag in place to work in conjunction with force. More of a made match in heaven scenario. So you can either bring in a drag, but because I'm dealing with leaves, anything with leaves, plastic bags, a piece of paper that you would like to, anything that you actually try to float and bring it to the surface calmly, I tend to use aerodynamic drag as opposed to drag. Drag is very intense, great for sparks, great for fire, great for let's say debris, anything with heavy physics in it. Aerodynamic drag works just fine, and it's actually perfect for leaves. And that's a new module we have never discussed. So I'm going to bring in aerodynamic drag and bring that in, and you can see the wind force, this little dot now turns blue, saying that you've got the necessary information in place. I'm going to say dismiss, and that kind of goes away. And now this aerodynamic drag is going to look after lift direction and the rotation of my particles. Another change this node makes is within solver force and velocity. Now, if I look at my solver force and velocity, you perhaps didn't notice a change, but if I go and turn off this module, aerodynamic drag, you can see it actually adds rotational solver to my solver forces and velocity, which can be extremely useful with light objects floating in the air. However, you perhaps notice this issue right here, because aerodynamic drag also has dependency. That dependency is called align sprite to mesh orientation. So I can type in align sprite to mesh orientation, and that comes in. And another benefit of having this, since we have chosen custom alignment and custom facing vector, this is going to ensure the correct display of particles in our level. And don't worry about the word mesh. It is not required to have a mesh renderer for the Niagara emitter to function properly. It's just the name of the module. And again, you're getting an info in here, which you can go in there and just simply dismiss. And we do not have any errors anymore. And if I click, you can see that instead of dropping, the wind force is now taking place and dragging the leaves to the negative Z. Before we go too far, let's place what we have in our level and just examine and investigate any potential problems. I'm going to go and drag and drop, bring it to somewhere around here, click away. And well, first problem is the leaves are going in to the ground, so we need a collision module. That's okay. But the aerodynamic drag is not really working. Some of these guys are floating predictably, and somehow there is not much spinning around the particle sprites. So we're getting there, but we're not quite there. If I select these guys, yeah, the drag keeps going all the way. I really want to target this area for the drag, and we're not really getting that. So aerodynamic drag, we need to make some tweaks, and we need to fix the collision. Let's get to that. For the easier one, aerodynamic drag, I really would like to randomize the aerodynamic drag intensity and have some min and max and take it from there. So we've done this many times. Anytime you have just a single value for a particular property, you can break it down into min and max and randomize it using random range. So type in random range float. I'm gonna give this maybe 0.1 to 0.2. The rotation, I want to sort of reduce this down based on my observation to something like, I don't know, 0.1 or maybe 0.2. That should do the trick. Also, this rotation, aerodynamic rotation, was what's really lacking. This strength, it's set to 1. I would like to randomize that as well. So I'm going to type in random range float and give it a higher value, something like 1.8 to 3, 3.2, let's say. We can definitely change those. And in the pivot, offset, min and max, I would like to make some changes as well, because they were just rotating from the center. Sometimes it is good to just randomize them ever so slightly. I'm literally putting just random values in there. I try to be careful not to put something like 20 or 30. These are minor adjustments, but it creates enough chaos within the rotation and make the movement a little bit unpredictable, because what I was seeing was just too uniform, for lack of better word, in rotation and of course in intensity. Now we have these two randomized nodes in place. Let's go and take care of the collision. Obviously, the collision happens in the particle update, and I need to bring in collision. Let's bring that in. It's going to place itself again on top of the solvent forces, and we would like to use CPU ray trace. Remember, we picked sim target as CPU. You can actually use GPU. When you use CPU, the modules will cast ray to calculate its collision in the world, which is something that we have already specified in the collision. But when you use GPU in your emitter, you switch here to GPU, then the method of calculation changes. The module will either use scene depth, global distance field, or GPU ray tracing to find collision surface. And of course, to have that GPU ray tracing, you need to have that enabled. Just for simplicity's sake, I've got 1390 and I definitely can use GPU, but for rest of us, if you wish to follow along and you cannot toggle between CPU, GPU, it's not a really processor intensive effect, so I can get away with CPU just fine. But just so you know, you can actually use GPU if you want to. I'm going to bring the particle radius bounds to something like 0.1, and then we have bounce and friction. Based on your effect, the type of effect that you're aiming for, you can switch to a higher value or lower value. I would like to have a lower restitution, and I would like to have a higher friction. I don't want the particles to slide too far. I would like to actually get a little bit of sliding, so that's why I'm not cranking up too high. And friction during bounce, something like 0.1. So I intentionally would like to get a little bit of slide on the ground, but not too far or too much. The other one that is kind of optional in this case, enable rest state, which I would like to actually turn off. And this attribute will pause particles that penetrate surfaces more often than the specified rate. It can be useful, but for now I'm going to kind of turn that off and see what sort of result I'm getting, and we will take it from there. I'm going to save. So remember, what we changed was within aerodynamic drag, we made some changes here, and for collision, we made some changes. Because I'm creating collision, I always would like to use a very useful module called Align Particles with Collision Plane. This surface right here is sitting on top of the floor plan, so I can easily go ahead and use Align Particles with Collision Plane. And that is going to help us to get a slightly better result. I'm going to lower it, bring it under solve and velocity, so it's not really affecting my force fields, so to speak. And in here, you can also tweak the alignments of your particles. Calming rate for bouncing, culminating rate for resting. For bouncing, I'm going to set that to 10, and culminating rate for resting, I'm going to set that to 20. That allows us to keep the particles on the ground when the collision happens. Rotational damping, maybe reduce it to something like 1, and collision normals interpolation, I actually tend to leave that as default. Now, the very important part in here, and one of the main reasons I would like to always bring in aligned particles with collision every time I use collision module, is this. Especially with something like leaves, you don't want them to hit the ground and stay in their y-axis or z-axis. So I would like to turn them off right off the bat, because yeah, it looks weird to have a leaf falling and staying on the ground in its y-axis or in this z-axis. So maybe X would be the obvious choice here. I'm going to save with my changes, and let's bring in this guy here, and I'm going to move it up ever so slightly, and we are getting a really good result right off the bat. I really like the effect right now because I'm getting a little bit of sliding. Wind is taking place. Maybe it's not as intensive. So I'm going to go into wind force, maybe push that ever so slightly. Maybe maximize for my wind speed scale can be increased to 0.75. Collision, and bump it up ever so slightly, something like 0.3 will do just fine, and maybe 0.25 here. I feel like these values are a little bit low. Let's have a look. Much better. So we widen the fall off where the particles fall on the ground, and the smaller ones drag a little bit. If you want to stop the drag completely, then bump up the friction value, and that should do the trick. But in terms of the look, that looks totally okay. I mean, based on your own scenario, obviously you want to make certain changes, but at least you know the workflow, you know the key properties to tweak, and you can totally take that from there. But for me, the fall off looks cool. The gravity works beautifully, and I'm getting the right orientation when the leaves collide on the ground. I hope you found this video useful. Definitely follow me on Instagram, Reddit, and X to know more about upcoming projects. As always, thank you for your support and for tuning in. Until the next video, see you guys later.